Bukan, ruangannya berubah. Kalau ruangannya berubah yang
kamera
tengah
ya.
berarti nggak ada cahaya dari luar ya. Paling dari
Katanya mau ganti ruangan.
iya.
Oh, oke.
900. Okay, so yeah, it's a bit hard because I have to inform the group and have to be so I don't use devices. Can I propose the other way around? I mean, I may sort of start to the yeah, whether the cost will be at 900 or so, but the
Iya, open. Bisa kedengeran nggak suaranya?
right? No
Linknya.
Okay. Will you wait first? I will ask one of the students, and then I will meet the first. So, first the 900 is free. Yeah. I get that. In the meantime, I mean, considering my condition, I will involve the supervisor and all my colleagues and social.
Posting di
It's a bit
WP ya.
hard for me to within 20 minutes.
Ini udah ada di message.
Yeah.
Posting di WP. Mantap. Gua posting di WP deh. 50 slide.
Ini kok kedengeran?
Kedengeran? Oke.
I am asking for his friends also. Yeah, we go to London. Okay, thank you. Thank you very much. Okay, I will
Pindah
take
ya.
it and the lecture move to 900. Yeah, thank you. Wait, not previously, but considering the room condition, I'm a bit nervous, but now, yeah, it's okay.
Live screening nih.
Yeah, thank you. Thanks for your
Ini
help.
itu di BPI. Iya. Terus Anda.
Thank you, man. Siaran langsung.
Jadi harus pindah ya. Oh, mereka yang pindah. Apa sih lu pakai ini? Kemana? Ntar
Iya, bos.
besar juga ya. Apa? Kita besar. Jadi apa bawa pulang? Lalu bilang apa? Nanti ada.
Itu gue tarik pakai.
Ya makanya gue udah bawa ini.
Ya maksudnya. Ini gue outin.
Udah ada ini.
Good luck kita.
Mantap. Bentuk ruangannya. Ini kita.
Sekretariatnya nggak ngurus.
Ya kan gue udah di book dari bulan April, gue kasih emailnya. Dia dari Blackboard kadang-kadang udah perlu.
Harus ke timetable.
Ya nelpon ke BLZ-nya, terus BLZ-nya dapat ruangan kosong. Jadi gue disuruh pindah. Wah gila gue informasinya banyak banget terus pindah grup kalian ke.
Tanggal kan?
Apa setengah 2?
Udah.
Setengah 1.
Gila di kampus setengah 2.
Oh banget ngomong udah haus.
Ngomong apa kita? Ini apa lagi sih kita? Temennya.
Kalau isi komitenya di belakang.
kasihan kok meja komisi ada di mobil, kasihan bisa di apa. Tanda tangan buat diplomanya di mana, Dik? Oh belum ya? Oh iya, masih internship ya.
Komentator dulu dong, komentator. Pada pemirsa. Kita lanjut. Bagaimana menurut Anda? Bung Olan dulu, Bung Olan. Jalan langsung dari host. Sampai 9
Hai Baratna.
Tanya lagi. Saya berubah kali 2000. Pasti kayak sidang lagi. Itu ada bedanya. Bedanya lebih santai aja, lebih santai. Terus habis itu nanti ke mana trek? Iya, trek. Besok punya gue. Iya tuh. Iya, udah janjian sama orang sih mau lihat
Di mana nasib kan?
nggak bisa dapat itu kayak apa dulu kayak di sini. Oh sih. Bisa tetap
Panjang banget.
itu juga 4,6 kan? Sama juga ya. Apa emang standarnya segitu? Tapi
Dipakai manis ya.
murah ya.
pejabat.
Ini di mana housing ini lebih besar. Iya, sepokan besar.
Oh ini.
Oh itu ada dua.
Jadi ada live loh itu?
Ini udah live. Tapi dia ada delay berapa detik?
Oh ya, ini
Ini yang live. Mantap ya. Nanti si Omai
teknologi tingkat tinggi. Hebat.
kemarin saya mau nyoba streaming yang
Grogi,
cooking klinik itu, cuman nggak dapat internet.
Sekarang ya. Once in a lifetime. Businessman kenapa pakai kaos?
Woi.
nunggu ini dicoret gini enggak? Ini tetap gitu.
Aku tadi sendiri malah.
Oh iya.
Apa tadi?
Pejabat gubernur lapangan ada di demo duduk malam.
Dari setahun lagi.
Lah. Ini udah live belum sih?
Udah, cuman di live.
Bukan. Oh, si Tegang mau nonton Mas Handika sidang malah ada Muhammad Agasta ada. Aja. Si Tegang. Sial.
Kamu udah masuk situ?
Ya suruh pengen.
Turun tangan. Kok bisa? Apa-apa.
Kurang sana.
Apa-apa, Mimir.
Kurang sana. Nah, ya gitu. Situ di depan situ. Iya ya.
Tangga jalan. Emang udah live? Dis?
Udah, cuman delay gitu. Jadi
Waduh, malu berapa?
Emang aja lu ah.
malu bohong.
Gini itu enggak.
Tuh kan baru datang.
Iya. Lagi turun tangga.
Kalau detik itu ya.
Suaranya ada juga nih.
Ada
juga.
Ada.
Iya.
Iya.
Aduh, Mas.
Iya, yang sudah lewat.
Terus ini langsung terekam di YouTube itu ya.
Langsung terekam ya, Mas? Oh, yang
Dia dengar kita pada ngomongin dia. Tau gak? Dengar.
Hampir pirang.
Istri pun tentang apa ya? Sama kayak lo. Beda ya? Beda dengan mereka.
Jadi sampai sini juga beda semua.
Bio energi. Itu teknik industri.
Teknik industri ada ininya, ada matematikanya.
Tapi asalmu
Ada
apa?
computer science.
Asalmu apa?
Teknologi.
Kok bisa dapat?
Hah?
Kok bisa?
Bukan
Jadi cari tuh harus ini ya, harus linear banget ya kalau kan.
jalan suratan.
Iya ya.
Saya S2-nya kan kebetulan ibu bisa masuk. Terus waktu S1 ada pengalaman apa sih kerja sama itu kayak udah biasa waktu soalnya mereka mau dia udah punya model. Nah, model ini mau diperbaiki supaya gimana caranya kan Belanda ini butuh renewable kayak buat ini. Jadi
Pinjam
masalah terbesar di renewable fuel itu transportation cost dari sourcing region, jadi dari region
Jamban, jamban yang gitu.
satu strategi dengan costnya murah itu kan Belanda nyiapin infrastrukturnya, entah itu jadi terminal atau misalnya kerja sama mana. Nah, gimana caranya bikin model supaya ngasih arahan di lokasi mana satu transportasi dengan biaya yang paling murah. Bukan yang paling
teknologi juga sih jadinya kan perencanaan pembangunan fasilitas infrastruktur.
tapi oh ya infrastruktur yang ada
apa itu?
Bukan kayak modelnya digabung tuh model ininya sama ada yang bikin desain makronya desain target sih 2018 ada satu daerah yang terminal pembangunan sama yang ada itu berupa apa sih minyak gitu harganya sih ada oil minyak ada wood stock yang dari kayu mahal dan mantap.
Kalau sampai ke sana
Belum berarti
udah tadi yang ada dari susah.
terus kamu pindah dari tempat kos yang sekarang mulai kapan sih? Kamu mulai pindah dari tempat kos yang sekarang apa nih? Pertengahan Juni deh Juni
Udah banyak yang komentar.
masuk Islam ya kan lu memang jangkauan Islam kamu juga harus ditambah lensa kamera yang itu harus ada handicam pas berarti kan bisa pengen nyari kita masalah atau kalau tempat
Oh, bukan.
properti mbak properti nanti habis ini mau syuting besar buat FM jadi nanti yang buat menginvite teman-temannya ya gitu hah? Enggak, maksudnya kayak session live aja. Jadi kita ngomongin kan. Buat ya. Datang kan. Campur. Ada nggak?
Keep it out. The mic. Oh, this is the camera.
Yes,
I was looking. I thought. This is the camera, right? Okay, good morning, everybody. Welcome at the Masters Tennis of Handika. That's for the friends that know that teacher during the talk, Handika, work, takes some 20 minutes. Then there's discussion, primarily with committee. Committee is also on the first slide. That is standard actually on the page. Then session and program. There's also, of course, last question from the audience. After that, we will go and discuss about grades. We will assign to this project and then we'll come back. Okay.
Good morning, everyone. My name is Handika. I would like to welcome you all to my master's review. And today I would like to deliver a presentation about biogas standardization, CO2 utilization versus biogas upgrading. This project is directly supervised by Dr. Wilhelm and Dr. Natasha for organization and Dr. Blair at the board of the committee. This presentation will cover introduction, data review, market selection, selection of process concept, process flow diagram, techno-economic evaluation, and conclusion. So, start. What is biogas? Biogas is a mixture of gases typically contains methane, carbon dioxide, few amounts of nitrogen, and also hydrogen sulfide. And biogas is generated mainly by the breakdown of organic material in the absence of oxygen inside used by vegetable. And the biogas uses material the fuel contains methane. At first, biogas is directly combusted and it is typically applied in an household application and also a small scale power engines. However, it has low energy efficiency because of its low heat value. Therefore, the removal of non-combustible gases needed in order to increase the heating value, and it is purified until a certain level of methane called warm index. By doing that, biogas can be injected to natural gas grid and also can be used as a vehicle fuel. Nevertheless, both applications still do not answer the CO2 reduction issue to prevent the greenhouse gas emissions. Therefore, recycling CO2 into a certain renewable fuels or synthetic hydrocarbons seems to be an interesting option. and it offers neutral or even negative CO2 balance. And as might you remember that CO2 content in biogas is quite high, until 40%. So actually biogas is a good resource of CO2. But there are two main considerations here because CO2 is a quite stable compound, high energy input is required, and liquid products are not desired to save space in storage. Considering these conditions, this study is aimed to provide alternatives for chemical liquefaction routes to utilize CO2 in biogas. And the selected process route will be compared with the current biogas upgrading technology in order to know its competitiveness in terms of techno economic evaluation and also process efficiency. This study is performed at a capacity of 1,000 kg per hour biogas, equals to 5 tons until 10 tons kilogram per hour organic materials, and only water wash and membrane separation are considered as a benchmark technology. So, how do I approach the objective until the conclusion? There are 3 steps here. First one is literature review and market selection, where I collect all the possible technologies and also selection of end product based on their potential market. Second step is selection of process concept, where I evaluate the conceptual process blocks, equilibrium conversion, first economic evaluation, and process efficiency. Last step is process flow diagram, where I build flow sheet construction and also determine the operation conditions and integrate the EPQ. So, what are the available technologies to incorporate CO2? I found 4 big categories which I summarized from a reference. First one is inorganic mineralization, where CO2 is basically precipitated in the magnesium or calcium rich streams, and the product typically sodium carbonate and limestone substitute. However, we have to compete with very cheap feedstocks, natural limestone, especially for a cement industry. Second option is organic carboxylation, where the whole part of CO2 is incorporated for organic compounds, typically urea, acetic acid, dimethyl carbonates, and polycarbonates. But only few developments have been demonstrated in current research. But considering the price competitiveness, the first option can be discarded, while the second option is open. Third technology is gas injection, where CO2 is reduced to form more reactive compounds by using a higher potential of reducing agents such as methane and also hydrogen. The main one of this technology is syngas, a mixture of carbon dioxide and hydrogen, from which methanol, formic acid, coal, and dimethyl ether can be synthesized. But high energy input is required because CO2 is a stable compound. The last option will be biochemical conversion, but algae plays an important role here because it can be harvested for its carbohydrate content, protein content, and also lipid, especially to make biodiesel. Once again, for example, biodiesel, we have to compete with the current price of fossil fuels. That's why the last option will be discarded, and the third option is still open. So besides technology, I also investigate the annual pollen production as their potential market. Competing in the high volume segment will only make, let's say, like a new technology suffering because we have to compete with cheaper feedstock, cheaper end products, and also more mature technology. On the other hand, penetrating into a low volume segment still questionable because a lot of uncertainties such as high risk failure and also potential customer is we can count it by hand. So the selected end products will only be methanol, DME, DMC, and acetic acid. So so far we already squeezed the option into 4 options of end products: acetic acid, DMC, methanol, and DME. And now we move to the next section where some of these options will be eliminated. First, conceptual flow is built for acetic acid. The special attention must be given to the bit energy where the sign is positive. It means that this reaction cannot take place instantly. And looking at this graph, even though at the extreme condition at 2000 Kelvin and pressure of 200 atmosphere, the methane conversion is extremely low, in around the magnitude of -5. Therefore, this route is discarded. Then we come to methanol, DME, and DMC conceptual flows. The first diagram is for methanol and DME, while the second one is for DMC. And biogas swimming for both routes are given a deadline because it's not a mandatory step. So it will depend on the required feed gas ratio to the syngas reactor. So next step is an investigation on equilibrium conversion for syngas. So the simulation is performed at atmospheric pressure with temperature between 400 until 1000 degrees Celsius, and I simplify the composition into 60% of methane and 40% CO2 for the basis. And as you can see in the table, all the reforming reaction except dry reforming could with methane conversion above 95% at temperature 800 degrees Celsius. Moreover, the dry reforming technology could only give hydrogen to CO ratio maximum 1, and unacceptable because we want excess hydrogen to form any kind of selective end products. Also, a higher requirement of energy and high risk of cooking will occur in dry reforming section. On the other hand, dry reforming seems to be a good option because it can achieve autothermal balance. But we have to put oxygen inside the reforming tube. By using pure oxygen, quite expensive. By using oxygen from air, we will put high content of inert. And also, it's difficult to control temperature inside the tube because of the combustion reaction. So, only steam reforming and dry reforming will be further analyzed as a part of methanol, DME, and DMC production. So, then I investigate the equilibrium conversion on methanol synthesis at the pressure between 40 until 60 bar and temperature between 230 until 300 degrees Celsius. As we can see from the below figures, selecting the temperature is quite obvious. Lowest temperature will give the highest yield, but selecting the pressure is a bit challenging because we have three options: 40, 50, and 60. And then basically my selection is will be based on compressor capacity and compressor duty. So compressing the system up to 40 and 50 bar will use the same classification of compressor, two-stage compressor. While if we want to increase the pressure until 60 bar, we will have to use a three-stage compressor, and it will cost roughly 20% of from the initial two-stage compressor. And again, the required electricity can increase up to 20%. Therefore, I select 50 bar instead of 60 bar to make it to make a saving in terms of compressor capacity and heat. Then I investigate also the equilibrium conversion for methanol and DME co-production, which perform at a pressure between 30 until 50 bar and temperature between 230 until 300 Celsius. And I select temperature at 250 because as we can see, there is no quite significant difference in terms of CO conversion. So at all pressures, so we can apply the lowest pressure as possible. And I select 50 bar for this case. Last, last one is methanol DMC co-production. I take these values from a journal, so I didn't do any simulation for it. It will be performed at 12 bar and 105 degrees Celsius and yield 10%. So after maximum conversion is investigated for each route, first economic evaluation is calculated here. By using this price table, we can see that methanol and DMC co-production seems to be the best option because it gives the highest revenue, while methanol sole production and methanol DMC co-production are on the same level. On top of that, all these foods still give 4 until 5 times higher revenue rather than biogas upgrading. In terms of process efficiency, again, methanol and DMC co-production seems to be the best options. Mass efficiency, high mass efficiency, high energy efficiency, and high CO2 reduction. But after doing some research, methanol and DMC form azeotropic mixture, and it means that we have to invest more on separation steps. And then methanol and DMC co-production gives the lowest mass efficiency and also gives the lowest CO2 reduction possibility here. Then bioreforming has lower steam to carbon ratio, 0.4 compared to 0.6 at steam reforming. So selected process concept will be methanol production via steam reforming. So until now we have eliminated 3 options of imbalance and 3 options of reforming sections. Now the selected process route will be optimized in terms of process conditions and also integrate the heat utility. To start this optimization process, a base case scenario is set, as we can see here, and the major challenges for the whole process are addressed. For instance, heat utility integration, cooking phenomenon, and also low methanol yield. So, since external fuel is less desired for a sustainable process, internal fuel source is strongly needed. Then there are 2 potential internal fuel sources I can find that the first option is biogas itself by splitting it to be combusted instead of reformed. By doing that, the recycled syngas, the unconverted syngas can be recycled back to the methanol reactor to produce the methanol yield. I call it the recycled steam. And the second option, I use unconverted syngas to be combusted, since it still contains hydrogen and carbon monoxide as combustion gases. And be utilized for reforming the reactor here. I call it a single pass steam. Then to start the optimization process, first I want to explain about how to prevent cooking phenomenon here. As we can see, x-axis shows the steam to carbon ratio, y-axis shows the temperature. The gray area here represents the cooking zone, and the white area here represents the safe zone or non-cooking zones. But be careful that pressures also give significant effect here. We can see this solid black line is a borderline for 30 atmosphere. And if we reduce increasing the pressure until 10 atmosphere, this borderline will shift to the right side. Okay. So it will increase the risk of cooking by reducing the pressure. So our best case scenario is 0.6 at 800 degrees Celsius on here, and we have to shift it in order to bring it to the safe zone. How do we do that? Increasing the steam to carbon ratio by remove the CO2 scenario A and adding steam scenario B. Also, we can mitigate the risk of cooking by increasing the pressure instead of atmospheric pressure. scenario C. And also we can increase the temperature a bit towards the minimum pressure scenario D. And then each scenario has its own benefit and loss in terms of these three parameters: hydrogen to CO ratio, cytometric number, and methanol yield. As you can see, for scenario A here, the cooking CO2 needs additional infiltration biogas upgrading itself. So it needs another investment instead of investing the money for only making methanol. So its mass is higher, and in addition, maximum steam to carbon ratio only can only achieve 1. And looking at this figure, steam to carbon ratio at 1 here, still have a potential, potential, especially if pressure is high. And then we move to scalar B because steady in practically it's more similar to removing CO2, and we have to bring it from 0.6 until at least 1.5 here to make it safe enough if we apply lower pressure than 10 atmosphere. And scenario C, basically scenario C, we increase the pressure because somehow syngas need to be pressurized to enter the methanol reactor. Despite its low performance, compressed biogas is more convenient rather than syngas because it's higher density. And I investigate several questions of pressure. Increasing the pressure up to 10 atmosphere is interesting. We still can have 80% methane compression, while there is a great saving in terms of compression in night operation with the simulation. But if we increase the pressure further than 15 atmosphere, the cost of methane compression, while there is no significant reduction in compressibility. So, pressure of 10 atmosphere is different, but we have to maintain the steam to carbon ratio at 1.5, and perhaps we have to increase the temperature also in scenario D to help the methane compression. And it will be discussed in the next slide. So basically this is the heat utility integration. Recycled steam compared to the single pass steam, and recycled steam is not preferred because of several arguments. First, we have to allocate more biogas to the combustion instead of reform. Second one is negative stoichiometric numbers. The third one is high volumetric flow without any significant incremental in product flow rate. You can see only 40 kilo per hour between recycle and single pass scheme, and also lower purity compared to the single pass scheme. And looking to the single pass scheme, only at temperature at 850 degrees Celsius, you can allocate full biogas to be reformed, and also highest methanol products here. So, considering these conditions, and to conclude this section, an overall flow sheet is constructed here. So, biogas is to be compressed in the atmosphere. Steam is provided in the atmosphere also. Both things are being used to enter the reforming reactor. And after reforming the reactor, we have to compress the syngas and separate the water. And after methanol reactor, we have an installation of flash system to recover the methanol, and also the unconsumed gas will be burned as a fuel. And this flow sheet already considered effective from putting the syngas, putting the flue gas, and also putting the methanol reactor because of its excellence. And this process can produce produce uh, approximately 6,400 tons per year of methanol, and so basically they export 2,600 megawatt hour per year electricity. So up until now, we already squeezed the options, optimized the conditions, and we now enter the techno-economic evaluation. So four main equipment has been designed here. First one is methanol reactor. The configuration is multi-tubular reactor with boiling water and 10 pumps as coolant. And it has 200 tubes. Each tube has 21 millimeters in diameter, and the height is 7 meters. The tube bundle itself will have a diameter of around 44 centimeters. The second equipment is recording record. The configuration is the same on this same conversion and atmospheric as the UV. So there are 20 tubes. Each tube has a diameter of 78 millimeters with a height around 10.8 meters and capacity of 2 meters per second. And the third equipment is heat exchanger. There are 6 units, and I just make an average, not an average, but an overall dimension here. The length is ranging from 1.4 to 4.2 meters, held from 54 and 60 to 25. And the last equipment is flashed down for units with a height of 2 meters and diameter of 50 centimeters. So to build this plant, I need almost $3 million, and compressor takes the largest part for the reactor. In terms of production cost, I can get a revenue around $2.6 million per year, and production cost $2.3 million per year, with raw material takes the largest part, here. And by splitting these two, I can get a profit of around $0.3 million per year. In terms of process efficiency, as we can see, after utility integration, the value is shifting to the lower value, almost a half of it. And special attention to CO2 reduction because high energy input will shift CO2 reduction process to CO2 production, mainly driven by the syngas conversion. But because the biogas is considerably renewable resources, it doesn't contribute to the addition of CO2. And if we compare to biogas upgrading, mass efficiency is sustainable. But however, a thorough investigation needs to be done in terms of energy efficiency and CO2 reduction here. So I cannot compare it right now. And then in terms of the economic terms, the capital cost is almost double from the upgrading, while production cost of methanol production is almost 5 times or 6 times higher from the biogas upgrading. So to conclude this study, most promising route to utilize CO2 in biogas is methanol production via steam reforming at a certain operating condition here, 10 atmosphere, 850 degrees Celsius, carbon ratio 1.5 for reforming reaction, and methanol synthesis at 50 bar and 250 degrees Celsius. And it can be considered as a self-sustainable process because no external fuels are needed, and even we can export electricity. And also we can call this process competitive enough because, as we can see, that methanol production cost equals to its commercial price here. 68 cents compared to the 67 cents. And some recommendations, experimental activities must be done on biogas film reforming because kinetic expression needs to be validated and monitoring on fogging phenomenon, especially for the selective carbon ratio. And thorough investigation on energy efficiency and CO footprint in biogas upgrading. Perhaps plan layout construction to see how large the required area is and actualization of this concept by developing a pilot and I think it's quite so I would like to say thank you to Win for nice discussion, even challenging discussion, and so for his guidance, and also to Dr. Sanka for his advice, especially on sizing. Sizing is a main component here. And so Dr. Position shifting me from bioreforming to steam reforming. So it will change the whole conceptual flow. Dr. Lea for his advice in the economic, practical, industrial application. Just burn the fuel, just burn the CDS, and then it's unfinished. And to all the colleagues from STP Group for helping me giving me advice, and also to PPI, Indonesian Student Association, for making today feels like home. And also the last one, but the important one, is my family support me the whole brilliant study. Okay. Thank you. Terima kasih. Thank you,
Let's start with questions. Well, we have yet, Handika, and very interesting work you did. That's 30 minutes presentation now. There's a lot of work in it. I think it shows. I have actually one question because I'm from industry and you always get questions like, what is my profit? What can I gain? And let's say I'm someone in Netherlands has 3 million euros or dollars, and I have to make a decision. I have to put it on, put it in the bank, and then and then I get a little bit of money. I can build a biogas plant, so the free gas, and the upgraded gas, gas, and then I think $1.5 million or so to work to get the free gas, and I still have $1.5 million left. Or I can build yours. So it's $3 million almost, and how much expense I get money. But it's results in great day.
If I may ask you, what is the best rate of the bank?
Zero. It's very low at the moment. So, you ask a very easy question.
Well, I can offer you, I calculate roughly around 7 until 8% in terms of return. So it's higher enough compared to the bank interest rate. So I think that's one point. And compared with the biogas upgrading, I would say I can, let's say, invest to this process because it's, I don't know, it's new but high risk comes to the high gain also. But we don't know what is coming. But the problem is here. I think the profit is quite low compared to the investment that I need. So to make it, let's say, to make it more profitable, there are several, let's say, concepts that can be applied in this study for further study also. The first one is, yeah, how to, let's say, recover methanol as much as possible. And also, I still here use conventional efficiency to convert steam to electricity. So quite low, like 50. I only use 50% efficiency. So if we find more efficient in terms of steam generator, and you can export electricity. Most of equipment that, let's say, is outsourced. So we export steam, and the high efficient machines will do its own, which is owned by, let's say, all communities, and then the electricity is there. You can ask for everything it will increase the profit. But in terms of production costs, no, in terms of capital investment first, compressor array and data are the main components here. But I cannot switch the money here. And in terms of production cost here, how to before low moment of biogas, yeah, I think it's waiting. But yeah, I believe I will just this is okay.
That's good answer because it's really long time on this. If you are an investor and you want to buy the race, you always opportunity in the race. And this is like sellability of the product. Price going up or down. Yeah. And our price to is are some months that nobody needs that more and the price will be down and we have to plan that
yeah, actually, once again, I only have 50% of internal price that it comes from ISIS. So to be honest, I cannot say the fluctuating price of methanol. But I believe because it is a commodity, that's why I choose it. Because it is commodity that every month I predict that every one of companies still need it. That's why I don't want to penetrate the low volume segment. But I don't have the exact answer of the fluctuation of price, but because it is commodity, I believe there will be consumer there.
Handika, thank you very much for the nice, very good conversation. I also, and we talked also about these things. I like that you are very open and you ask all questions. Very nice. Thank you. You have understood most things. Two things I would have seen, I won't ask you a question. I would have thought which would conclude from your everybody or things from the bar. I thought would have been better than feeling I get from all the background knowledge I have. I don't think we change the version. That's and the second thing to make it more interesting was that colleagues actually asking people when techno things are doing stuff. That you could also add and not just make that but that makes it that would make it even more interesting. But I want to, I know only a little about the others, not all these things, so I should ask you something about, I have two questions. Rates. You write somewhere in one of the page 20, you write a rate for reaction. On the left hand side, bottom equation 17. Rate is equal to rate constant times concentration. Yeah. And before that, you agree that these reactions have a lot of performing problems. and on condition. In this only and make flow carbon dioxide. So that's agreement. So you always have to on because that is. Now you write a rate which is equal to rate constant time particle. Okay? And before that you write a lot of equations. You explain what happens. So what happens is you break down anything, something in the carbon or something like that. And you need to oxygen. Oxygen you use from water or thermodynamics. They are very stable, so you cannot do that easily. My problem is now, this is something I have long distance from my colleagues. I think they are from it doesn't matter. When I look at the situation, if there is no concentration or water or CO2 then or CO, right? I will say here that it's one way in carbon that is heat source. So it means that heat solves that by water or heat that is fast. If that is never gets down. This is something like I have this difficult, so we have never any problem because you're all this one. Never any problem. You can work at 0.8 This makes sense. Maybe it's difficult, but my question then to you is, do you think it's an oxygen or
I'm afraid no. Because I studied also several another things about it. Because the power of partial pressure of methane is high, the highest, and while the others is only 0.1, even below 0.1, and can be directed by high performance applications. Also, the using that kind of expressions, but somehow the result is was slightly different than what this was completely so a lot and also absorption term as the denominator. So
you understand the concept?
yeah. Because the other
Works based on carbon species. So it's very hard. So it's hard to this one thing. Quite difficult to understand conceptually, one, and second, considering the fact that CO2 and water are not
yeah. And also I also the method itself looking at the looking at the figure 7, I think it is obvious enough that the methane breaking here will actually increasing exponentially at the temperature of at 50. So
it's always puzzles. Public information. It's okay, but you can think about it, and you never have any problem. So, I go into the advantages, disadvantages, technique for biomass. Page 9. You compare many methods, absorption with water, absorption with telephone, means, processing, and brain credit. I'm taking the simplest absorption with water. Then I read your disadvantages. Cannot find the water. I do not understand. Why would I have a simple thing like absorption with water? Always.
Yeah, I actually I took it from a journal that I want to interpret this like this, and it's not like yeah, investment. All the technology has the same problem, expensive investment, and bacterial growth because we use water. It's a convenient zone for bacteria to grow. Forming because bacteria growing and CO2 and from
I understand you say, for example, I have a special example, ethylene oxide. Ethylene oxide, so ethylene oxide was zero. It's separated by running that mixture through water for 20 meters, 20 bar pressure. That's all. And it's a commercial process. I work in it. But there is a problem. I can imagine it's not regular. Okay, you mentioned some ethylene. So we some solution. But in all, it's okay. I mean, that's it. The very thing is only for is like that's linked to it's a problem. Then it's not a real problem. So hours it was equal to 5 to 10 tons per hour organic material. How do you think of outside the scope for the think of integrating the rest of the material your process more from on a kilogram basis 4 tons per hour are lost to what they
I wouldn't collect the organic material, let it decentralize on basis and collect the biogas itself in the piping system and make it centralized to make this specific. I think it will be more convenient than transporting full organic material. Let's say like milk or only few 20% maximum dry or transporting like gas itself
you not integrate your part you can
you know like gas lights
and another maybe related question maybe goes on rock. Did you mention it that an exception for an export? That's a little more. Let's suppose you're at a location where export is not really direct.
Yeah, if we cannot export electricity, we can use excess, perhaps in terms of pressure. So actually, my only selection is let's say like for the can actually uh, higher pressure by using by doing that more methanol can be used at the expense of higher temperature and also or I let's say what's that maybe to increase the I mean I can use it to run let's say I can further increase the select I can follow entity rather than only
you would be able to buy the electrolytes and
so yeah yeah because
in the interface of the people.
okay in that configuration I would say uh, if I can install an electrolyzer and I can I could oxygen and I can put an oxygen combustion part and perhaps put the unconverted gas like that but not all can help so the chemical and the technology the content
You then have to read the whole section feature or say one.
I can receive it first as the external an external equipment and I take I think that I need buy a certain how much and then integrate into the podcaster when I compare a hydrogen
At the end, in answering the questions, I think from the you mentioned that about the investment was high risk. Is it really a high risk? So where is how would you invest?
actually in terms of equipment the risk not that high because the dimension I commercial and from areas for the reforming reactor and also the methanol reactor. So the risk in terms of equipment not that high, but validating the whole process. I don't know yet because it's pretty hard, and then perhaps there is a big gap with the actual and the part. That I call the high risk rather than of it.
It's far and like several days for the
Yeah, I would like to say the reforming rate, the reforming action first, because I propose to use lower carbon rate rather than commercial ones on rate, but I only 1.5. It is good enough to prevent. Then I don't run the system. Then I can sell the electricity. That can I can prove that study is effective enough. So that is the first one. Yeah, also the main the second main part. Yeah, yeah. But in different systems, yeah, it is quite small and require user to cooling the system via boiling water. operate use of the method.
Let's think of something. I understand that that your small carbon ratio is lower than last year's forecast. So why would this work? There is the, I think, potential decades, 50 years of catalytic development, formal development. Less than 50. What was the great for it? Why would it work for your small carbon ratio?
I think I don't know. Reading the introduction part of the journal that I here itself. Uh, the main point that they want to display the pressure, testing pressure, and how the so there is no catalytic yet. Uh, but yeah, the study was aimed to let's say the amount of heat in the plant. So yeah, obviously relating to the experience, second opinion experience, and then the effort to reduce. I don't know how I can relate it, but that is an effort. Yeah.
The first step is and there's one more technical thing, and I like about your said yes, but something that buy can you buy stress burner? Those special technology. Yeah.
Uh, First, I have to check the motivation first. So yes, if the rate and in the commercial burden, but otherwise I can express the need of special burden.
Good. Question from you. Yes. In one of the first slides, you showed that there's also H2S gas, biogas. I was wondering where it is in the process, or
Yeah.
it doesn't react as a catalyst, it must be reformed or methanol react.
Actually, H2S is dangerous compound, and yeah, it can be active catalyst. Yeah, that's why let's say I make a boundary of the scope, not to include the H2S first, because otherwise it's let's say too much parameter that I have to monitor. That's why in the simulation I mentioned that I simplify the compositions to methane and 40% oxygen. But for sure, H2S is the end. We have to limit my study first. I assume that
Yeah. Yeah, it was a very nice presentation and overview. It will be hard to compete with commercial methanol processes because they are at least a factor of 100 bigger, and they have, of course, benefit of scale in this case. So there should be somewhere a difference when you want to compete with them. You could say maybe on the oxygen plant. What was in this case? Did you use oxygen or did you use air in the reforming section?
air almost.
Okay, so that's a saving because you don't have to build an oxygen plant, and as this size that will be terrible. So that's but that means that you at the end you have get a problem of a diluted stream to get methanol out. After your methanol reaction, you have a lot of nitrogen in there.
No,
No,
because the combustion itself takes place in outside box of the reforming tube. So this is the reforming tube,
yeah.
and then
Okay, if you don't, yeah, okay. That's if you don't have the nitrogen, then it's, yeah, it's reforming, but yeah. Okay, so that's you have solved that part then. That's you don't have the oxygen plan, as in methanol as well. That makes it cheap. When you compare this process with, let's say, making the gas and add and feed it to the natural gas grid as green gas, because that's another option. Eh? Take the CO2 out, feed it with green gas in it. What would then be the benefit?
In terms of economics?
Yeah, economic benefit.
Yeah, I already explained it. It was double in terms of capital investment compared to the biogas upgrade.
Okay, so it's biogas upgrading is, yeah, it's double. Yeah. And how much do I earn at the end? Because that's the capital cost.
Yeah, roughly speaking, the upgrade biogas minus the raw biogas minus the production cost. So, yeah, roughly speaking, I don't calculate quite exactly. Yeah, 37 cents minus 15 cents,
yeah,
24, and minus 14 cents for Mexico, so 10 cents profit per kilo.
Yeah. Okay, the methanol price you assume here is the market methanol price.
Yeah, market.
You could say that's the gray or black methanol. In your case, you make green methanol or not? Because it's bio-based. And green methanol, yeah, is more valuable than the gray or the black methanol.
Yes.
Your market price of methanol can be positively influenced by
1.5 years ago, the profit is 5 times higher than 3.3.
Yeah, just to give an example, when you look for a company in the north, methanol, BioMCN, yeah. They apply a trick for the glycerol you get from the biodiesel. Yeah. And that methanol, you can sell it, and you get a certificate attached to that methanol, and then you are allowed to use 2 times the heating value of that methanol if you are adding it to the fuel. So that means roughly it's getting 50–60% more valuable than the commercial methanol. And that's for the time being, yeah. That makes it then interesting.
I think it's already remarkable that you're right, you're completely lacking this economy of scale.
Yeah.
Yet you arrive at roughly still.
Yeah. Okay. Thank you.
Let's go to the last question. Yeah.
Just a little bit out of my from what the sales price effect on 2008, so it was like yes, can be higher than higher, so you can get more profit. Yes, with the tagline, yeah. And the other thing is, you said about return on this kind of investment is like 7 or 8% compared to interest rate in Holland, which is just nothing. Don't you think that you should sell this to some economic entity? Yeah. Yes. I love that.
How do you think about it? That's final.
I ask you the question my boss from.
Okay, Handika, thanks again. We'll be back, but on the basis of that, sometimes 50 minutes. Maybe 20 minutes.
Jadi gue sempat galang kan agak black terus gue mulai tahu. Oh itu maksudnya. Ini mana tahan? Tagline itu kan. Mana? Bulan lagi lega. Kalau memang profesional susah nangkep kalau bedanya dia susah dikira banyak makanya tadi gue serius tapi untungnya dia nggak ada apa-apa ya pokoknya banyak banget reaksinya gara-gara ngomong itu makanya yang dikejar bukan max skill tadi kan dari 1000 kan cuma 400 kan tadi masih bisa profit dikit lah kenapa lagi pas dia lagi ini langsung sekarang habis pengumuman dia tuh temenan sama misalnya
Harusnya sih bisa.
Aku nggak bisa sih. Soalnya terus kan pengen dari awal aja gitu.
Harusnya sih bisa.
Bisa ya.
Jam 1.
Jam 1.
Padahal tiap pindah blok kita mulai lagi latihan. Sidang beres 19 Agustus ya.
Dia bilang gitu. Tapi ngomong. Dia paling tinggi. Katanya sih kemarin sempat baca emang di gitu terus yang gede dia kan awalnya dari kecil ya dari awalnya dari jadi suami istri gitu bikin stand biasa gitu terus udah jadi nggak tahu sih belum nemu juga nggak beda apa awalnya dari masa kecil keluarga nggak tahu beli franchise-nya atau di luar negeri udah ada di Indonesia ada. Iya makanya belum jelas sih. Dia tuh siapa target yang masih deh. Kalau dulu kayaknya gitu sih karena ke kesehatan kesehatan. Apalagi ya makanya mungkin akan bikin yang mahal gitu. Bisa jadi. Kalau kita sendiri juga pasti kalau bahasanya sedikit kalau mau kita paling bahasa Belanda kondisinya kayak apa